All right, morning everyone. Okay, here we go. We just spent 7 minutes kind of going over our notes to review stuff. What's the name of this? Distributor. This is a distributor. Okay, again, you are going to need to know to identify this when you go in the shop to do the lab. Okay, if the car has something that... You're not going to see this bottom part, Emerson. Okay, you're just going to see this top.
What did I miss yesterday?
Kind of looks like a crown.
The yellow one.
Distributor. What's the name of this?
Where's mine?
Direct.
This is a direct ignition system. Okay? So this is a direct ignition system. Now, specifically, this is called a coil on plug. Okay? But it's part of a direct ignition system. Coil on plug. Okay. What's the name of this?
Distributor-less.
Distributor-less. Okay? If you didn't get this in your notes, this is also called a coil pack.
If I was up there, I would have it down.
This is a distributorless system. You can hear me, right? You don't need to see my voice.
Distributorless system.
This is a distributorless ignition system. This part here is called a coil pack. Okay? This could also be called a waste spark ignition system. Okay? A distributorless system could also be called a waste spark ignition system. Okay, but this particular component is called a coil pack. Yes?
Will we get into power eventually?
Not as detailed as you would think. Okay, when we get into our intake systems, we do talk about turbos momentarily, just so you understand kind of roughly what's happening there. We also get into superchargers. Chase.
I mean, what sound does a supercharger make?
Stop.
Is there a difference between like factory installed
Typically no. I mean, there's some stuff there that the factory might have, that the third party won't.
You might like the factory.
All right, lots of talking for whatever reason. Hi, Emerson, face forward.
How do I get in trouble?
Jonathan, I don't know if you know this or not, but your front of your face is much more pretty than the back of your face. It looks like, you got
I like the back
a
more.
massive beard back there.
I like the back more.
Okay, so face forward. Thank you. Gerardo, you also go over there.
Come on, man.
Hi. If that would be the case, then I'm going to stick you up right here.
Whoa. Go ahead and do it.
Emerson, hi.
What do you mean? I'm literally
Just go sit back over there, please. That way you're not distracting Emerson or Jonathan.
No. No.
Okay. Emerson,
Bitch, ain't it?
Emerson, your goal is to not say a single word from now until 8:44.
Oh, hell no, Jigsaw.
Chase. No, I don't have any room up here, guys. You guys can't see. Get glasses. Okay, sorry. All right, we have to move on. Okay? All right, yesterday we ended up talking about dwell time. All right, obviously that is a vocabulary word that I hope you circled in your notes because that's going to come back and be very, very important later on when we talk about spark plugs. But in relationship to our ignition coil, our ignition coil is going to convert the 12.6 volts of our battery primary circuit into 30,000 plus volts in our secondary circuits by using magnetic fields, by creating an electromagnet. We create a magnetic field, we shut that circuit off, magnetic field collapses, which then energizes that secondary circuit and pushes the electrons at a much greater force. Okay, we develop that pressure, electromagnetic pressure, in our circuitry. Now we have enough voltage to push the electrons across a gap at the spark plug.
How quick does this happen?
Milliseconds.
Too quick.
Okay, it's extraordinarily fast. Okay. Now, the good news is, as a technician, I'm going to show you guys, we have tools that I'll actually get into, and we can measure stuff, and we can use that to actually diagnose what potentially could be wrong with our ignition system without ever taking anything apart, which is pretty fun. All right, getting into our direct ignition system. That's going to have an ignition coil mounted over the top of each individual spark plug. Okay? So, what happened to my ignition coil from yesterday?
Did you not just have it?
It's in your hand.
No. Well, this is my coil on plug. I had my normal ignition coil floating around here yesterday. I'll have to look for it. But anyways, oh no, here it is. It just blends in. Okay, so here's my ignition coil. This ignition coil, back in the day, worked in conjunction with this distributor. So this one ignition coil was producing all of the secondary voltage for each cylinder in my vehicle. So this thing was firing 4, 6, 8 times more because it had to go through all the spark plugs. And then the the electrons that were coming out of this at 30,000 volts was then being distributed to the correct cylinder that needed it because it was reaching TDC through this thing. Okay, so this worked in combination with this. Now, thankfully, through technology, we've taken the ignition coil, we shrunk it down, and we literally put it right on the top of this. And now each individual spark plug is going to get their own individual ignition coil. Okay? And now I don't need to distribute that secondary circuit voltage because it's directly hooked up to the spark plug. Okay, that's good because now all of a sudden I'm not having any loss over a distance instead of using like a spark plug wire, like what you would see on this, on the distributor system. Okay, now some systems, like I said, have a coil on plug like this, or, whoops, I didn't even touch anything. Some may have what's called a coil near plug, meaning that this system basically is chopped off and we're sending that voltage to the spark plug, but it's not a very great distance. It's just shifted off to the side a little bit. Okay, so you can see here, let me get my drawing out. So there's a coil near plug where my spark plugs are right there. Okay, so I got a tiny little spark plug wire that goes there. Otherwise, the reason why it's called the direct ignition system is because the ignition coil is literally directly on top of the spark plug. So this is where the spark plug would be. That's a horrible drawing. It looks like a snake. You get the idea. Okay? All right, here's just kind of a quick wiring diagram of what that might look like on a computer or on a vehicle. Okay, I got my control module. This is a computer. Okay, whoops. So my computer system. Here's all my spark plugs. So spark plugs are right here. In this case, I've got 4 of them. And I've got an ignition coil, which is this piece right here that sits directly on top of that spark plug. And just like before, what's happening is this computer control is taking a switch. Let's see if I can draw a switch. Right? And it's either flipping it on or it's flipping it in the off position. So electrons are able to flow into the ignition coil, creating that magnetic field, and then it's flowing back in here. Okay? And then when it flips it off, it cuts that circuitry off, collapsing that ignition or magnetic field, and then we send the electrons down. Boom, right here to where it fires the spark plug. Okay? That's kind of the rough idea of what we talked about here. All right, an ignition system uses this to change battery voltage into high secondary voltage. Oh. Well, you gotta hold it up a little higher. You gotta get off your phone for 4 seconds.
Yeah, Juan.
Hey, where's the thing that shows
They
you?
got you, man. They got you.
Yeah, that's only on bell ringers.
Aw.
I think I got everybody. We'll find out. All right, 3, 2, 1. Okay. Hey, 79% of you guys got this correct. Juan, what'd you pick?
C.
C is the correct answer. Coil. Okay. Our ignition coil converts the 12.6 volts on the battery into 30,000 secondary volts for our ignition system. Ignition coil. Yeah,
You should like get new ones of these and stuff after that, so.
I should. Thank you for the suggestion. Yeah, I know. That's what happens when people are using and abusing it, right? They draw on things all the time.
I was picking B when I was trying to pick C.
Emerson, why do you get your Chromebook out?
Because I'm still doing this.
She's doing his reassessment.
Yeah. We're not doing a reassessment now. We're doing this.
But I'm doing two things.
No. No. Put the
Isn't that
Chromebook
just
away.
so cool?
Please put the Chromebook away.
But like I'm almost done with this question.
I appreciate that, but please put the Chromebook away.
But like I'm literally a couple.
Emerson, hi. I acknowledge that you want to work on the reassessment right now.
I'm like 3 words away from being.
But at the same point in time, I'm asking you to please put that away.
But like I'm literally 3 words from being done. Watch, just watch.
Emerson, please put the Chromebook away.
Get out of my phone.
Yeah, they could take computers too.
Emerson,
I'm literally putting it away.
no, you're not.
No, actually, no. Please don't
Shut up.
call the office now.
Chase, hi.
Skillian.
No one asked for your input or feedback.
Damn.
So if no one asks for it, no one wants it. Emerson,
Right there. You see? Couple words. I just type a little bit slow, okay?
thank you very much. Sammy, you had a question?
Have spark plugs changed over the course of the
Yes. Yes, they have.
A lot or a little?
Generally speaking, their design is probably very similar to what you would find 40, 50 years ago. The materials have changed significantly. And we'll get into that a little bit, maybe.
Just more electric conductive? Or
No, not so much that, just more resilient to the
so
environment that they're living in, so they last longer. Okay, ignition coil is the correct answer for this particular question. Spark plug doesn't convert anything. All it's doing is creating a gap to ignite the air-fuel mixture, so that way that generates the spark. We don't really even have a bypass circuit in this case. A ballast resistor, that's made up. So there we go. All right, engine sensors. Because again, we have to acknowledge that the fact that the computer is monitoring and turning on the switch on and off. Okay, as I alluded to earlier to Easton's question, right? It's milliseconds. This is happening in milliseconds, faster than you can probably blink your eyeball. Okay, so that means if I'm driving down the road and I'm responsible for turning on and off the switch, I'm not going to be able to do that effectively enough to be able to run the engine. Okay, remember it's like jumping rope. But instead of doing it like 15 times over 20 seconds or whatever, we're doing this thing thousands of times a minute. Okay, I can't react fast enough to that. So we have to have a computer control do it. Well, how does the computer know when to turn the spark plug on and off? Right? Doesn't have eyeballs. Okay, doesn't have ears. Well, technically it does, but we'll get into that later. How does it know? Well, it's going to use some engine sensors. Chase, put the phone away, please. Gerardo, put the phone away, please. Juan, put the phone away, please.
Hey, Cacho. You too. No, you
Look in your pocket, please.
Look at mine. Look at mine.
All right, engine sensors. These are literally going to be monitoring the process of the operating conditions of the engines as things are happening in real time. And again, these things are monitoring thousands of times per second. Okay, it is on a scale of speed that we can't comprehend as human beings. We're too slow. Okay, so what's ending up happening is that sending that electrical data, that it's transmitting that information as it's seeing it to the computer. The computer is then programmed to react to the data that it's seeing from these sensors, and then it's making a decision based off of programming to turn that switch on and off. Okay, so that's how it affects the when and how. Okay. Now, the reason why we've gone over to this is obviously for couple of reasons, right? First off, we're maximizing our engine efficiency. We are literally micromanaging and controlling, Easton, the amount of gas and air that's being mixed together and how we are burning that. So we are not wasting a single drop of energy in an efficient manner. Now, on a side note, we have to understand that internal combustion engines are still inefficient in regards to its use, right? It's not using 100% of the energy that we're burning in an air-fuel mixture. Okay, we're probably only using about 20% of it. 80% of it gets converted to heat. Okay? But we want to try to maximize that efficiency as much as possible. Okay? This also helps increase the performance of my engine. So nowadays you're seeing that there's a lot of 4-cylinder engines out on the road that's got 300 horsepower, 400 horsepower. That's ridiculous. Okay? Getting 100 horsepower per cylinder is not normal. So how do we do that? Well, this is one way that we can control that. Okay? Now I can be running around in a Honda Civic as a high school student thinking I got hot stuff, and that if you transported that vehicle back in the 1970s and you raced against some of the vehicles back in the day, you'd beat them with a vastly, quote-unquote, inferior engine. Okay, but that's because the technology is so much greater. This also increases your miles per gallon, right? Hey, I can put in 10 gallons of gas and I can go much further down the road with that gas than with anything else that I might see. This is why you're seeing V8 engines no longer being made. Okay? You don't need them anymore. Okay? A lot of people probably are upset about that because, more power, we need V8. Listen, you can take a V6 engine and you can get the same horsepower or greater than a V8. So thus, we don't need them anymore. They're more efficient too. Yeah.
Brandon is very disappointed by that.
But exhaust sound.
What the hell kind of wine?
Wait,
I'm simply telling you the facts of what's
What if we
happening
do like this?
with the
What if we do like
automotive industry. We are becoming so efficient on this sort of stuff. You're starting to see 3 and 4 cylinders taking the place of V6s. V6s taking the place of V8. At some point in time, V6s will also be going away.
What?
It's just going to be the matter of fact. And you will not know the difference.
Yes, I will.
You will get in a vehicle and go, oh man, this thing's got a lot of power. You open the hood and go, but this only has 3 cylinders. Yeah. Okay. It also has lower emissions. This is the big thing right here. By law, they have to have lower emissions in most of their fleet vehicles. Okay, so if I'm Ford, all right, I'm only producing F-150s at this point in time, and Explorers and SUVs. The only car I'm making anymore is the Mustang. Right? They have a calculator figuring out, okay, what's all the emissions rating on all your vehicles that you produce. If it's over a certain mark, they get fined for that. So they're incentivized to make more efficient engines. They're trying to develop this technology as much as possible to make that gas go as further as possible without any pollutants coming out, any more than already is.
I heard something, I don't think it's true, but I heard some people, they're saying that like 2,500 they're going to go to V6s.
I wouldn't be
That's not-
surprised. I wouldn't be surprised.
Oh, hope not.
Because again, it's not so much the energy of the engine, it's the transmission that allows you to pull stuff. I will tell you this right now, the F-150's EcoBoost V6, you get in that thing, that can tow just as much as a V8. Gets way better gas mileage than the V8.
Yeah,
and
well,
you'll never know the
17 miles a
difference. Okay? But there's a lot of technology that goes into that. Okay?
Okay.
Forced induction specifically. I mean, that's what an EcoBoost
It was
means.
like 10 miles to the gallon, and it's like $100, like $130.
All right.
Everything on it.
These 3 things, performance, miles per gallon, and low emissions, typically determined to be drivability. Yeah, I know Emerson's on the phone. But you know what? I've given up on him because he just doesn't care. And you know what? I don't care anymore.
Always snitching.
Huh?
Always snitching.
Well, he's snitching. Dude, your hands are like in your
They
pants
caught
and
us.
you're looking down. There's
They
literally
caught us.
no other reason why you are doing that other than having a phone in your lap.
No,
You guys think you're all cute trying to hide things? You're not. It's
Well,
crazy obvious.
I want to be you.
He wants to be a YN.
I don't want to be one of them either.
Anyways, drivability. So anytime a vehicle manufacturer talks about their drivability of the vehicle, increased drivability, they're talking about the increased performance, miles per gallon, and lower emissions that's happening because of that engine. Okay, and the ignition system has a lot to do with that. Okay, how does the sensor know when to tell a computer to fire the spark plug? Well, one of the sensors is a crankshaft. Well, hold on. I'm not going to get into the sensor quite yet. Okay, we're going to get into the crankshaft trigger wheel. Okay, that is a term. Oh, where does that come from? Hold on a second. That's a vocabulary word. Absolutely. Crankshaft trigger wheel. Could also be called a reluctor ring. Interchangeable, those two names. Okay, depends on who you talk to. I'm going to say trigger wheel just because I want to keep consistent with what we're talking about so it's not super confusing. Okay, and you can see here that trigger wheel on the outside of the engine. Okay, here's my vibration damper. So what part of the engine am I looking at? Okay, the crankshaft is, this bolt right here is bolted right into the crankshaft. So what part of the engine? Front or back?
Snout.
Snout, which is in the front of the engine, okay? So at the front of the crankshaft. On this particular one, the trigger wheel's on the outside so you can actually see it. It's bolted directly onto the crankshaft. Okay, can you see that? Now the fun part is as this crankshaft is spinning, so is this trigger wheel. It's also spinning. So as the crankshaft spins faster, the trigger wheel spins faster. As the crankshaft spins slower, the trigger wheel spins slower. So depending on how fast the crankshaft moves, we can monitor that live. All right. Now, the big thing here to keep in mind, it is going to be determining the position of the crankshafts. And that since the crankshaft is hooked up to our pistons, guess what we can infer based off of the data of the position of the crankshaft?
Where our pistons are.
Where our pistons are at in each one of the cylinders. Okay, this is the information that the computer needs to know, so that way it can send the data to spark the spark plugs. Okay, now the fun part about the crankshaft trigger wheel is that it is missing one tooth. Like literally, it's missing a tooth. Okay, so we got teeth here, right? Tooth, and all of a sudden, missing tooth.
So you're telling me if someone doesn't know what they're doing, they're just gonna look at it like, oh, it's broken.
Maybe, absolutely. Okay, so we got a missing tooth right there.
It's so it knows how many laps or rotations.
Every time this goes around, that missing tooth is going to send a very specific signal to the computer.
One rotation.
Now, it's going to send it each rotation, yep. Now, here's the fun part about this. What does that missing tooth represent? Top dead center of?
Cylinder 1.
Cylinder 1. That is very important to know. Okay? Steven?
How do you, like, when you install it, how can you tell where it is? Like, when you put the piston, or move the crankshaft so the piston's at the top?
So, yeah, part of the engine building process is everything goes off of TDC of cylinder 1. Everything. So when you're building that, you're literally manually moving it around once everything's kind of ready to go, and you're using a dial indicator and everything to make sure that you're at TDC at cylinder 1, and then every time everything goes off of that. So engine building is a very, very precision skill to have, and it takes a lot of time, because if you get that wrong, even by a little bit, it can throw off the ability of that engine to actually operate correctly. So the nice thing about this trigger wheel is that it has basically the ability to line itself up when you actually install it onto the crankshaft. So that way, that missing tooth corresponds with TDC, right? And if it doesn't, you can go into the computer program and you can actually reprogram the computer to say, hey, we're off by 0.1 millimeters or whatever. And then once you communicate that to the computer, then the computer, when that's spinning around, will understand to take that measurement off to know precisely where that's at. So that's getting into way more detail than I'd care to get into for right now. But all you need to know, missing tooth represents TDC of cylinder 1 piston. Based off of that, we can then know when TDC is in cylinder 2, when TDC is in cylinder 3, when cylinder 4, so on and so forth, okay? And that's because the engine has a firing order. Cylinder 1 fires, then you're typically going to have cylinder 3, then you're going to have cylinder 4, then you're going to have cylinder 2, at least in a 4-cylinder engine, okay? There's a sequence there that repeats after one another. So it's important to understand that firing order. The computer's going to expect that firing order, and then that's when it knows where it's at. Okay. So the crankshaft position sensor, again, that's another vocab word that we need to get down in your notes. Okay. This particular sensor is going to work in conjunction with the trigger wheel. Okay. Oops. Yeah, there we go. And it is literally going to be picking up the signal as this trigger wheel is moving around. Okay, let's see, let me move this out of the way. So as this is turning, you've got a tooth here that's got a high, a low, a high, a low, a high, and a low, right? And as that keeps going around, this little sensor right here is called a Hall effect sensor. You don't need to know that, but basically it's a magnet. And as this tooth gets super close to that magnet, right, it's going to induce a voltage. So now all of a sudden I've got a higher voltage. And then as this rotates around and it goes to the valley, the low part, right, now all of a sudden that voltage is less because it's further away from that sensor. Okay, then as this tooth gets closer, right, and we get an electrical signal.
That looks like the teeth.
It looks like the teeth. Okay, now I'm not going to get into the weeds of this, but basically the computer is seeing this and it's saying on, off. Okay, saying on, off. And it literally can count that. What do you think the signal looks like when it meets that missing tooth?
Flat. Oh. It's flat line.
Instead of having a tooth signal in my signal here, it's literally going to be like that. And then the computer goes, wait a second, there should be something right here. It's missing. That's TDC of cylinder 1. Okay? Now, this sensor then sends that signal to the computer. Okay? Just so you are aware. Go sit back down there. I'm not letting anyone else move.
Come on, you didn't realize.
So,
Come on.
again, I want to emphasize this because this is important for you to know. The trigger wheel is actually going to be monitoring the position of the crankshaft. The sensor is what's sending that data to the computer. Okay? The sensor is not monitoring the position of the crankshaft. It's sending the data to the computer. The trigger wheel is literally monitoring the position or rotation of that. Okay? There's a slight difference between those two. Okay? Slight difference between the two. All right, again, as the crankshaft spins, the crankshaft trigger wheel and the crankshaft position sensor or sensors produce an on-off voltage signal representing crankshaft speed and position. Okay, again, this is what it might look like if I were to look at it as a computer. Okay? And it sends that signal as a voltage signal. All right, and again, I'm not going to get into the computer side or electrical side of that because that can get a little overwhelming. But again, this trigger wheel and the sensor, they never touch. Okay, it's in proximity to another. That's what the computer sees. That's how it can read it. That's kind of the same way as if, hey, I walk into a room and there's no light. I can't see it, but I can hear something and I can kind of tell maybe where something's at. We're using our senses to figure things out. All right, the camshaft position sensor operates basically the same way as our crankshaft position sensor does. The only difference is the camshaft positions, monitoring the camshaft and its rotation. Why would we want to do that? Mr. Getzke, we know from engine fundamentals that the crankshaft is actually hooked up to the camshaft with a chain,
So something
the
happened.
timing chain, right? And we know that the crankshaft is actually then forcing the camshaft to rotate to open the valves, right? So why do we need to monitor the crankshaft and the camshaft? Can't we defer where the camshaft is based off where the crankshaft is? The answer is yes, you can. So why do we need to monitor the camshaft then? This is a very high level question, by the way. Chase, are you understanding this? Or are you still looking at your phone?
No, I understand.
I think you're lying to me. But hey.
I understand it now.
I understand it.
Okay.
Which one?
I'm going to take you back. I'm going to take you back here. This will be our last slide here. I'm going to take you back to our engine fundamentals presentation way back in September.
Oh, goodness.
Okay? This is why we can't forget this information because it builds off of. Okay? If I've got a crankshaft, how many times does that crankshaft rotate
4.
for every 4 strokes in the 4-stroke cycle? Twice. Okay? Rotates 180 degrees for the intake stroke, 180 degrees for the compression stroke, 180 degrees for the power stroke, and then 180 degrees for the exhaust stroke. Okay? That's crankshaft. Camshaft, how many times does that rotate for every 4 strokes in the 4-stroke engine?
4.
A quarter of a turn for each stroke. That means this thing turns 360 degrees. So intake, compression, power, exhaust. Okay, this is important to understand this concept because now if I'm monitoring my crankshaft and I say, okay, here's TDC of cylinder 1, how many times does TDC happen in cylinder 1 in the 4-stroke cycle?
1.
Say the question again.
How many times does cylinder 1 reach TDC in a 4-stroke cycle?
Twice.
Okay. Under what strokes do we reach TDC? At the top of the compression, as soon as we begin the power stroke.
And the top of the
Top of the exhaust stroke. Okay. So if I'm only monitoring the crankshaft, I'm going to achieve TDC twice. Which one do I ignite the spark plug at?
Second one.
I want the compression stroke, right? How can the computer tell the difference between TDC at exhaust or compression?
Because of where the camshaft is.
Is where the camshaft is at. Okay? In this case, the camshaft only rotates once. There's only one position as the camshaft rotates around that can communicate to the computer. This one is the TDC at the compression stroke. This is when we want to fire it. Okay? So that's crazy kind of higher level understanding of how an engine operates in order to understand the camshaft position sensor need. Okay? We're going to pick this up tomorrow again on this same slide because I'm not done because we need to talk about the NOx sensor and what that does and how important that can be in our engine. Okay?
Is that what door bell is for? NOx sensors?
The what?
NOx sensors? Is that what a door bell is?
I guess you could say yes.